Hello guys, welcome to Bugs in Code, and the problem that we are going to solve today is a single element in a sorted array. But before that, if you're new here and a person who likes stuff related to coding, then you can subscribe the channel so that you never miss out an update. So let's get started. The problem statement says that you are given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. Return the single element that appears only once. Okay, so here, let me take an example. Here's an array which is 1 1 2 3 3 4 4 and 8 8. So each element appears exactly twice except for one element, which is this 2. So for this uh, for this input, the output is going to be 2. So this is what the problem says, and even let me take one more example, which is 1 2 2 3 3 okay, and 4 4. So for this array, the output is going to be 1. Here you can see that 1 appears only once, and all other elements appears exactly twice. Okay, so your solution must run in O of log n time and O of 1 space. So but before that, I want you to get the intuition like how we get to the algorithm which will use O of log n time. So let me first start with the solution. So let me write here solution. When you see this problem, let me write the example again. So okay, remove this. Let me write the example again. So if I'm given array which contains 1 1 2 2 3 4 4, so the first approach that comes to our mind is what we can do. We can traverse this whole array, and we have to find one element where we have to find that particular index where the previous element and the next element is not equal to the current element. I hope you guys are understanding what I'm trying to say, and let me just okay, so let me just write this again. So I have to find that particular index for which if I call it array, so array of I minus 1 is not equal to array of I, and array of I plus 1 is not equal to array of I. So it is array. So this is the condition that we have to match. So what we can see for this one, there is no previous element and the next element is equal to the current element, so this cannot be our answer. After that, for this one, the same condition like previous element is equal to current element, so this cannot be our answer. Now we move to, so for I is equal to 0, uh, array of I plus 1 is equal to array of I, you can see that. Also for I is equal to 1, the second is I equal to 1, so we find that array of I minus 1 is equal to array of I. Now for I is equal to, the third one is I equal to 2. So for I equals to 2, we see that array of I plus 1 is equal to array of I, isn't it? After that, for I is equal to 3, what we see that array of I minus 1 is equal to the array of I. After that, for I is equal to 4, we see that the condition matched like the previous 0 1 2 3 4, this particular element, and for this the previous element is 2 and the next is 4, so this is going to be our answer. So I will write condition matched. Okay, so this is going to be our answer, and our answer will be equal to 3. So this is what we have to return. So what we can do is, what we are doing actually here is we are performing a linear search. So this is the first approach that we comes with, and let me just code this approach. What I can do is, okay, so I have to write I have to tell you some edge cases here, like for my I equals to 0. Let me just write this array again. So 1 1 2 2 3 4 4. So for this element I don't have any previous element, for this element I don't have any next element, so these cases I have to these cases I have to handle manually. So let me just do. And even one more case is if the length of array is just 1. So in this case I'm going to return this particular element because this has a single appearance. Let me just now write. So if my I will calculate my length as nums dot length. Okay, now I have to write the condition if n is equals to 1, then I'm going to return nums of 0. And else if my nums of 0 is not equal to nums of 1, then we are going to return nums of 0. And else if my nums of n minus 1, which is last element, is not equal to the second last element, then in this particular case we are going to return the last element. Now I have handled the cases for first and last index. Now let me define, let me start a loop with I equals to 1 and I smaller than nums dot length minus 1. So what we are going to do in this loop is we are going to check if my nums of I is not equal to nums of I plus 1 and nums of I is not equal to nums of I minus 1. So the current element is neither equal to the previous nor equals to the next. So in this particular case we are going to return the current element. Else I have to write one thing here. So this condition is never going to be matched, so I am just writing this condition for formality because my code is not going to run without this. Let me just run this approach. Let's see whether it works or not. So you can see it's working for the example test case, and let me just submit this. So this is going to be our linear search based solution, and let me see how fast it is. Okay, you can see it's 100% faster. I don't know how, but actually if I tell you, then it is a linear search based solution, and the complexity is going to be O of n. Okay, so what we can do is now we can, let's see whether we can optimize our code or not. So since the array is sorted, now I want you to give the intuition since the linear search can be applied here. So and we are given the array sorted, so we can think of a solution in terms of binary search here. Okay, so we can, the time complexity of this is going to be O of n and space complexity is going to be O of 1. Now what else we can do? We can use binary search here, but before that, before binary search, I want you to give one more solution that is going to be really very interesting. So guys, if you want to watch the binary search solution, then you can skip to that particular segment, but I am going to give you one more solution that is going to be a bitwise operator based solution. So we can use something that is bit manipulation here. How we are going to bit manipulation, it's going to be very interesting. So let's move. Now we have our array which is 1 1 2 2 3 4 4 and 8 8. So this is our array. Now what we can do is, we know one thing, that XOR of same elements, same numbers is always 0, always 0. So if you guys don't know this property, then you should remember this property because it is used in various different type of problems in the mm, bit manipulation topic. So let me write this. So A XOR A is always equal to 0. Now what we can do is we can use XOR here. So if I find the XOR of all the element, then the XOR of these is going to be 0. XOR of these two is going to be 0. XOR of these two is going to be 0. And let me write like this. XOR of these two is going to be 0. So what we can do is this element is something that will left when I calculate the XOR of all the elements. So when I calculate the XOR of these elements, so I will get 3. So my output is going to be 3. So what I can do is just just return the XOR of the elements. So guys, why I'm telling you all these approaches, because in the coding interview, an interviewer doesn't is not actually interested in the most optimized approach. Even he's interested in like how you are getting to this approach, that approach. So how, like what is your intuition behind that particular approach. So you guys are always going to start from the brute force. After that, if you guys then you are move then you can move to the optimized solution. So that's why I'm telling you this approach as well. So let me just code it, this approach. So it's really interesting, and let me just, even it is just a few line approach. Let me define XOR as 0 and 4, all the integers. One thing, let me tell you that Java also support the where keyword. So I can have where here, and XOR is equal to, now I'm calculating the XOR of all the elements, and at the end I'm sure that I will be left with only one element which has single appearance, and rest all will be cancelled out. So let me just run this approach. Okay, so it's working, and let me just, what I can do is I can write this approach in just few lines. So now it has become a 3-line solution only. So you may have seen various solutions in the Leetcode solution section, which says that only 3-line solution. So this is what a 3-line solution looks like. Now let me submit this, and it's working fine, and let's see how fast it is. So it is 30% faster. And now I have explained you two approaches to solve the problem, and let me just move to the final and the most optimized approach, which is our binary search. So what I'm going to do is I'm going to write here binary search. Binary search. Okay, so how we are going to apply binary search? Let's see here. We are given an array which contains 1 1 2 2 3 4 4 and 8 8. So here I want you to observe some things, like the first thing is this is 0, this is 1, this is 2, this is 3. These are the indices. So this is 3, this is 4, this is 5, this is 6, this is 7, and this is 8. So this is going to be the breakpoint. How this is going to be the breakpoint, let me tell you. The first occurrence of every number, every pair before this is at even index. So you can see that this is even index and this is even index. After the breakpoint, so let me call it breakpoint. After this, the first in appearance of any pair is at the odd index. You can see here that the first appearance of 8, the first occurrence of 8 is at odd index, which is 7, and for this 4 it is 5. So we can make the use of this thing here, this observation here, how we are going to have a low as 0 and one more pointer high as length minus 1. Length minus 1. Now after that, what we are going to do is let me just have a pointer. The first is here, the second is here. So we are going to find the mid element. Let's say whatever the mid comes, and for this I'm just taking a random index. So let's say this is the mid. After that, what we can do is, if or if the first occurrence of mid element is at even index, then our breakpoint is something in the right portion. So I will make my low as mid plus 1. So let me just write this. So if first occurrence of my of the current element is at even index, what to do then? If it is at even index, then we have not reached our breakpoint yet. So in this case, we are going to do low as mid plus 1, because our breakpoint will be something in the right portion. After that, what we can write is, if the first occurrence of current element is at odd index, what to do then? Then we are going to make simply our high as mid minus 1. Why we are doing so? Because if I'm somewhat at here, so what I observed it that I observe one thing, that the first occurrence of 8 is at odd index, so we are ahead of our breakpoint and we have to move backwards in order to reach our in order to reach our breakpoint. So this is what the binary search based solution looks like. And when we are going to return, so if my current element, the previous element of the current element, like previous is not equal to current, and next is also not equal to current, then return the current element. So this is going to be your solution. So let me just I hope you guys got the understanding of this intuition. So let me just code this approach. So what we can do is, we can have our previous solution, because I need those edge cases again. The edge cases are going to be remain same, and let me just now start the binary search. So how I'm going to do it, I'm going to have a low as 1 and high as nums dot length minus 2. Why I'm doing so? Because I don't actually I want to avoid the confusion which occurs when I'm at the starting position and the last position, because in this case I don't have either the previous or the next. So what I can do is, while my low is smaller than equal to high, then what I'm going to do, I'm going to calculate my mid as low, actually high minus low by 2, low plus. So this is nothing but it is same as low plus high by 2. So I write same as low plus high by 2, but it is generally written in order to avoid the integer overflow. Now let me check whether my nums of mid minus 1 is not equal to nums of mid, and nums of mid plus 1 is not equal to nums of mid. In that case, I have to return the current element, which is going to be nums of mid. After that, if this condition now is not true, then either my previous is equal to the current, or my current is equal to the next. So let me write this: else if my nums of mid minus 1 is double equal to nums of mid, then I have to do something, and else I can surely say that my next element is nums of mid plus 1, which is equal to the nums of mid. Now what to do here? Here I'm going to check, since the first occurrence is going to be my previous element here, so I will write nums of mid minus 1. If actually I'm just going to check if my mid minus 1 is odd, is even. So if it is even index, then I'm going to do my uh, low equal to mid minus 1. Else I'm going to do as high equal to mid plus 1. So this is what I'm going to do. After that, I'm going to check if my mid minus 1 is even, then I'm going to do my low equal to mid plus 1, and else I'm going to return high as mid minus 1. And this is all about the solution. Now I just need to return this solution, and let me just return minus 1. So this minus 1 is basically for the formality, because I can surely say that when this loop completes, so I will have my answer, which will be written by this statement. So let me just run this. There may be compilation error, but this problem should work fine. This solution should work fine. Okay, so what's the problem here? Let me see. What I'm doing is, okay, I have this thing, and after that, what I'm doing is, if my mid minus 1 is not equal to my nums of mid and mid plus 1 is not equal to nums of mid, then I'm going to return this one, no problem. Else if my previous is equal to the current, so what I'm doing is I'm checking whether my, okay, so in this case I have to check my current mid, because mid is going to be your first occurrence in this case. Let me just run this again. Okay, so it's showing time limit exceed again, but why? Let me see here. So what I'm going to do, if my first occurrence of current element is at even index, so I can see that the first occurrence is going to be at mid minus 1, and mid minus 1 index is even. So in that case I'm going to do my low as mid plus 1, no doubt. After that I'm going to, okay, so just make it mid plus 1 and here make it mid minus 1. This is the problem that we are facing. Let me just run it again. Let's see whether it works or not. So okay, so it's working for the example test case, and let me just submit the solution. Okay, so it's also working, and here I have explained you three approaches to solve this problem. The first was linear search, the second was a bit manipulation based approach, and the third one is the binary search. So this is all about this problem. I hope you guys like the solution. If you like the video, then you can hit the like button and also subscribe the channel. So thank you.